Dear students, welcome to Sia's digital classes. Today, let us learn the concept of procedure for difference of standard deviations. So, what is the procedure to obtain the standard deviations when two standard deviations are given in the question? So, how to do the procedure and all, let us learn. We'll call it as difference of standard deviation or two standard deviations. So, let us check it out how the data will be framed and how the formula will drag. So, consider two standard deviations. So, whenever two standard deviations we have, that is S1 and S2 I am considering here of two different and independent samples. So, independent samples I am considering here. Then under null hypothesis H0, there is no significant difference between two deviations. So, always we'll consider null hypothesis, there is no significance. So, there is no significance difference between standard deviations we have here, because our concept is about standard deviation. So, sigma 1 is equal to sigma 2 I am considering here for H0, because standard deviations, population standard deviations we are considering under H0 as they are not significant, in the sense they are mostly the same. So, next, hence for large samples the value of Z is given by. So, always in this unit we'll discuss about the large samples, right? So, all the large samples will come mostly from the normal distribution, the standard normal. So, the same formula what we have learned in SEM 2, the same formula will drag here and we'll try to implement that into the standard deviations. So, how it will be converted, let us check it out. So, Z is equal to, because it's a standard deviations we have, formula will be S1 minus S2 by standard error of S1 minus S2 it will be, which is we got from standard normal distribution, that is with the mean 0 and variance 1. So, that symbolically we wrote here, that comes from the normal population. So, that I have considered as equation 1. Now, let us check it out how the changes will go on, in the sense I need the value for standard error. So, let us derive standard error, that too again from the normal populations. So, also for large samples the following is the standard error for the difference between two standard deviations. Yes, difference between two standard deviations we have to consider, and a standard error we need to obtain, so that we can go for Z, substituting in Z. So, standard error of S1 minus S2 is equal to root over sigma 1 square by 2n1 plus sigma 1 2 square by 2n2 becomes a standard error, because these is a variance. If you remember, from normal population we are considering normal population, it is a mean is mu and variances are sigma square by 2n it will be. So, because 2 we have S1 and S2 2 we have, so variances will be sigma 1 square by 2n1. So, both of them we are adding here, sigma 1 square by 2n1 plus sigma 2 square by 2n2 root over, because it is the standard error we have, right? So, standard error means root over variances we consider. So, here we got this equation. So, let us substitute this into the Z formula and we will obtain test statistics for the standard deviations, two standard deviations. So, let us check it out how the substitutions will go on. So, by substituting equation 1 and equation 2 we get Z is equal to upside values as it is, that is S1 minus S2 as it is, divided by standard errors. Just now we have obtained the value, right? That is root over sigma 1 square by 2n1 plus sigma 2 square by 2n2, that I have substituted here. Now, this becomes the formula for our difference of standard deviations, and of course they'll come from the normal population with 0, 1. So, that we specified here. Next, we have different situations based on the data. If they specify sigma 1, sigma 2, how to utilize the formula. If they don't specify population standard deviation, instead of that, if we have sample standard deviations, how to go for the difference of standard deviation formula. Let us check it out, that different formulas also. So, here it's next, if you don't have sigma 1 square, or if we have sample standard deviations, how the changes will happen to the formula, let us check it out. So, where the information about sigma 1 square and sigma 2 square is not known, that's what I have just now I said. If that information is not available, that is sigma 1 square and sigma 2 square, that is population standard deviations are not available, then how to handle the formula? Let us check it out. And hence their estimates provided by the sample variances are used. So sample variances are available for us, and we don't have standard deviations or population variances. We don't have sigma square, right? Sigma square means it's a variance, population variance. So population, instead of population variance, if we have sample variance with us or standard deviations with us, let us check it out how the formula will be changing. So for large samples, again the corresponding test statistics is given by, so instead of sigma 1 square, I have S1 square, that is sample variance with me. So I can rewrite sigma 1 square with S1 square, because for large samples we can consider them as a population standard deviations, as a sample standard deviations or variances. So formula will change. Instead of sigma 1 square we can write S1 square, instead of sigma 2 square we can write S2 square. So that is your sample variances, we can resubstitute. So this becomes a one more formula. So taking this formula is based on the data given question, whatever you will obtain. So based on that, if at all population variances are available, go for the first formula. So instead of population variances, if sample variances are available with us, we can go for this second type of formula. Standard deviations are given, we can go for the root over, like that also we can assume. So this is your difference of standard deviations, obtaining the formula for difference of standard deviations or two standard deviations whenever we have in our hand. This is how we'll proceed with the data. So these are the formulas. This is a standard formula what we are using. Out of that we have obtained two different situations. This one when population variances are there, and this one when sample variances are there. So this is the concept of difference of standard deviations in testing of hypothesis procedure. So hope you have understood this procedure. See you all in the next session. Thank you.